Alright, we'll get started. This is CIS-125. Now I'll abbreviate here. Intro to Program Logic. And this was 8/27/14, I believe. Wednesday. Okay. Here we go. We started out with a problem. We said we have a dowel rod, and what we need is we have this sheet of fabric. We need where to cut the fabric off to fit the dowel rod and where to cut it here so it wraps around the dowel rod exactly, and we can glue it on or whatever. So what we did was we created a way to understand how to do that process and have it done the way a computer would do it. So we talked about a few major things, and I'll highlight those as we go through. You must understand the problem to start with. You have to understand the problem when you first start. So the first thing we work on is the wording, to make sure we understand the problem. Usually start out with what you want for the output. Here we need to know the length, and we'll just say this is the length here, and how wide. We'll say this is how wide here. So how long and how wide we need to cut the fabric in order to fit the dowel rod exactly. So what information would we have to input? Well, the students immediately almost work this way up. To get the output, we would have to calculate the circumference. And somebody came up with the formula: circumference equals the diameter times 3.1416. We mentioned briefly about significant digits and that, but we're not going to get that detailed today. Okay? In order then to get the circumference, which is going to give us the width, the length, once that's inputted, we know that, so we don't really have to do any calculations. We just have to figure out where to cut it here so that it wraps around it. Okay? So the one piece of information that we need to do that would be the diameter. So then we work our way up and we get the input. Okay, what are we going to input? We can input the diameter and the length. So this is called an IPO, input process output. Now we need to use things to represent these, what we would call variables. Okay. Probably you could think of this more so as storage locations. So we have a, so we have, did I put that back about in the right place? I'll maybe move it a little bit more here. Okay. So we have a processor that's going to do the work, and then we have memory. In memory we have places we can store things. Okay, So we're going to use variables to represent where we're going to store things. We could use the full word, or sometimes it's easy to use a letter for clarity. So we'll work with both ways in the class. So here we're going to use the letter D to represent diameter, L to represent length, and C to represent the circumference, which is representing the width that we need. Okay? So let's take a look at how we came up with the solution. So I'm going to move, and so let me go to give the solution. We can flow chart, and we have pseudocode. The pseudocode is here, the flow chart is here. And at the end here we'll give you some names for the symbols here in the flow chart. So our process, we have a start. So like step 1, we're going to enter the information in. That's an input. Step 2, we're going to do our calculations. In step 3, we're going to produce some output, give the results in step 4. And in step 5, we're going to stop. So here, we're going to enter the diameter and the length. You can see the variables there. You can find those over in the legend if you were to go back and look at that. And then this is important. You know, in order for a computer, these pieces, so we have the processor. The processor is going to get an instruction from memory. So let's say it's got instruction number 2. Then it's going to gather the D and the L, and it's going to have a place in memory where it's going to put those values. So actually, that would be like this. It's going to come back and put them in memory. Then then it's going to go get the next instruction, fetch that instruction. Here it comes into the processor. The processor looks. The processor is going to calculate what's on the right and store it in the left. I will go over that and over that lots of times. Okay? Process what's here and store it here. So it's going to say it needs D. It's literally going to grab D, bring that up, put it in a register. Then it's going to take this constant. It'll do the arithmetic and put it in what's known as accumulator. And then it'll send those results here. It's going to send those results back down here. So it's going to create a place down here for the results and store it in something called C. I'm trying to make this as messy as I can. Not really. So then the next step, let's say we're on step 4, it's going to print L and C. So it's literally the instruction. The instruction is going to come up to the processor. The processor is going to say, I need L. So it's going to go down. It's going to grab wherever L is, bring it up. It'll grab wherever C is, bring it up. It'll perform the function, and then it'll stop. And that's what we indicated here in the walkthrough. Perform the step. Actually, it's going to print those two things, and those things end up staying in memory. Okay, I don't want this to get too long. Okay. I think that will be it. All right, let me finish up. Had a little tafu there. So here are the boxes we've covered so far. Okay, we have a start and a stop. Maybe I could do this. We could say blue is start, red is stop. Okay, this is an assignment box. It'll do the work on one side and assign it in the location you give on the left. So you would always, your formulas would have a variable and some kind of calculation. Output, this is for printing, and we'll have other type of outputs later on. We have flow arrows. They should go from box to box, down and to the right as best you can, and they should just touch the boxes. That should just touch. So there's no indecision on where it's going. This is a read box and this is an input box. And we'll talk more specifically about bringing data into the process. And that's it.